So we were discussing some problems of applications of derivatives. So today also we'll discuss these questions, application of derivatives, and tomorrow we'll start the new chapter integration. See, we were discussing this question. The sum of the perimeter of a circle and a square is k. So that is why 2 pi r plus 4x is equal to k. We have to prove that sum of their areas is least. That means we have to prove that area is minimum. So area is equal to pi r square plus x square. Circle ka area pi r square, square ka area x square. We have to prove that this is minimum when the side of the square is double the radius of the circle. That means when x is equal to 2r. That we have to prove. Now, so this area, you can see that this is in two variables, r and x. So we have to make it into one variable. So this is from the above step. From here, you will get 4x is equal to k minus 2 pi r. So आपको उसमें से x मिलेगा, which is k minus 2 pi r divided by 4. So this is equal to pi r square plus x is equal to k minus 2 pi r the whole divided by 4 उसका square. So which is equal to pi r square. You can expand that plus you can see that in every term divided by 16 is there. So upper a minus b the whole square. So a square minus 2ab plus b square. So a square k square. So उसके denominator में भी 16 आएगा minus 2ab. So 2 into 2 4 pi k r divided by 16. A square minus 2ab plus b square. So 4 pi square r square divided by 16. So हमने तो expand कर दिया. So इधर ये कट हो जाएगा 4 and 16. इधर से 4 आएगा. इधर भी 4 and 16 कट हो जाएगा. 4 आएगा. So this is equal to pi r square plus k square by 16 plus k pi r divided by 4 plus pi square r square divided by 4. Now we have to find derivative dA by dr, because if the maximum or minimum exists, that will be at the critical points. So we are differentiating with yes
माइनस आएगा ना वहाँ.
हाँ तो इधर माइनस आएगा. ठीक है that is minus. Okay, so we have to differentiate. Thank you. We have to differentiate with respect to r. So pi r square, derivative of r square is 2r, so it is 2 pi r. Then k is constant, 16 is constant, so derivative is 0 minus k pi divided by 4 is constant. Derivative of r with respect to r is 1. Then plus pi square is constant, 4 is constant. Derivative of r square is 2r, so 2 pi square r. Now for maxima or minimum, for maxima or minima, derivative dA by dr should be is equal to 0. That implies 2 pi r minus k pi by 4 plus 2 pi square r square, sorry, pi square r divided by 4 is equal to 0. So from these two terms, like 2 pi r, and from these two terms, from that two terms we can take r common. So that implies r into bracket में आएगा 2 pi plus 2 pi square divided by 4, and k pi by 4 right side में जाएगा, it is equal to k pi by 4. So it is nothing but pi square, ये कट हो जाएगा, pi square by 2 आएगा. So which is, so आपको मिले, that implies r into in bracket it is 2 into 2, 4 pi plus pi square divided by 2, which is equal to k pi by 4. So in other words, that implies r is equal to 2k pi divided by 4 into, in bracket, 4 pi plus pi square. So here actually you can take k constant, like, okay, it is 2k pi divided by 4 into, you can take a pi common, so बाकी 4 plus pi आएगा. Then this pi cancel हो जाएगा, 2 4 cancel हो जाएगा, 2 मिलेगा. So that implies आपको मिलेगा r is equal to k divided by 2 into 4 plus pi, 2 into 4 plus pi, 8 plus 2 pi, whatever it is. So now we got the critical point. Now at the critical point there may be maxima or there may be minimum or point of inflection. So we have to check it. So we have to find the second derivative, d square a by dr square. So इधर लेफ्ट साइड में dA by dr है. So फिर से differentiate करना. So 2 pi r, 2 pi constant, derivative of r is 1, minus k pi by 4 constant, derivative 0, plus 2 pi square r. So उसका derivative r 2 pi square by 4 constant, r का derivative 1. So 2 pi plus 2 pi square by 4. You can see that this is a term independent of r. There is no r in that. So कोई भी value उधर substitute करो, r के लिए कोई फर्क नहीं पड़ेगा. So therefore d square a by dr square at r is equal to k divided by 2 into 4 plus pi. r के लिए कोई सब्स्टिट्यूट करने के लिए उधर कुछ नहीं, सिंपली 2 pi plus 2 pi square divided by 4. It's a positive number क्योंकि 2 is positive, pi is positive, so it is greater than 0. So the second derivative greater than 0, मतलब that means area is minimum at r is equal to k divided by 2 into 4 plus pi. Now we have to, okay, now we proved that the area is minimum when the radius is k divided by 2 into 4 plus pi. But हमें prove करना है कि the side of the square is double the radius of the circle. So left side I will write. So when r is equal to k divided by 2 into 4 plus pi, x is equal to, so हमारे पास फॉर्मूला था, x is equal to 1 by 4 of k minus 2 pi r. K minus इधर formula, इधर हमको मिला था 4x is equal to k minus 2 pi r. So from there x is equal to 1 by 4 into k minus 2 pi r. So which is equal to 1 by 4 into k minus 2 pi into r. R is equal to k divided by 2 into 4 plus pi. So ये 2 कट हो जाएगा. एक सेकेंड. Yeah. 2 कट करेंगे. So which is 1 by 4 into, it is 4 plus pi into k minus pi k the whole divided by 4 plus pi. So which is equal to 1 by 4 into, अब देखेंगे तो 4 into k 4k plus pi into k pi k then minus pi k minus pi k cancel हो जाएगा, divided by 4 plus pi. So which is equal to 4 कट हो जाएगा, k divided by 4 plus pi. So you can say this is same as 2 into k divided by 2 into 4 plus pi, क्योंकि वो 2 कट हो जाएगा, क्योंकि इसलिए मैंने अरेंज करके लिखा है कि दैट इज 2 k divided by 2 into 4 plus pi is r. तो इसे वो दिखाने के लिए ऐसे दिखा है. ठीक है. सो x is equal to 2r. तो इधर हमने थोड़ा सा अरेंजमेंट किया है, k divided by 4 plus pi. So we have to prove that that is equal to 2 times radius. So it is 2 into radius is k divided by 2 into 4 plus pi. The in effect 2 cut हो जाएगा, same you will get, but this inside the bracket this is equal to k is equal to 2r. Inside the bracket there is r, so it is 2r. Clear?
Yes,
Any doubt?
सर अगर k की वैल्यू सब्स्टिट्यूट कर दे पहले से तो वहां पर r इज इक्वल टू
k का वैल्यू किधर सब्स्टिट्यूट करेंगे?
सर वो डायग्राम के नीचे है ना यहाँ पर.
उधर क्या सर k का वैल्यू क्या है? 2 pi r plus 4x.
हाँ वो करेंगे तो
ठीक है, फिर भी r का वैल्यू सब्स्टिट्यूट करना पड़ेगा ना. तो 2 pi r plus 4, सो x तो उसमें से क्या मिलेगा? आप सब्स्टिट्यूट करेंगे तो क्या होगा? देखो 2 pi r plus 4x सब्स्टिट्यूट करेंगे तो minus 2 pi r कैंसिल हो जाएगा, 4x by 4. दैट मीन्स यू विल गेट x is equal to x. वो तो सही है, बट तो हमें बट उसमें से कुछ रिजल्ट नहीं मिल रहे ना.
यस सर.
Okay, we will go to the next question. Okay. Another question. Show that the altitude of the right circular cone of maximum volume that can be inscribed in a sphere of radius r is 4 by 3. So here altitude of the right circular cone of maximum volume. that can be inscribed in a sphere of radius r. तो हमें इधर कौन सा चीज मैक्सिमम करना है? व्हाट वी हैव टू मैक्सिमाइज? right
Volume.
yeah, volume of the right circular cone. So it is inscribed in a sphere. So it's a sphere, but I can draw a circle here. I'm just drawing the circle. So इसके अंदर अलग अलग डायमेंशन का कॉन हम इंस्क्राइब कर सकते हैं. मैं एक रफ पिक्चर ड्रॉ कर रहे हैं. So this is one cone inscribed inside the sphere. Let O is the center of the sphere, and given that radius of the sphere is r, it is given a sphere of radius r. That means this is fixed. This is equal to r. Sphere of radius r. So हमें प्रूफ करना है कि इसका जो volume of cone is maximum when altitude of the cone, height is equal to 4r/3. This is what we need to prove. Volume of the cone is maximum when height is equal to 4r/3. So let r is the radius of the sphere. So height of the cone, here is a height of the cone, you can see. This is the height of the cone. So let this distance is O. तो कल भी हमने क्वेश्चन किया था. सो दिस डिस्टेंस से इसको हम x कॉल करेंगे. सो बाकी जो r होगा, सो आपको मिलेगा हाइट इज इक्वल टू r प्लस x. Height is equal to r plus x. Now we have to find the formula for the thing which is to be maximized or minimized. So we have to find the volume of the cone. Volume of the cone is equal to 1/3 pi r square h. तो इधर हम दूसरा एक लेटर यूज करेंगे क्योंकि r is already used for radius of the sphere. So r square h, because this radius, this is r, that is the radius of the base of the cone. Small letter r is already given, it is the radius of the sphere. That two are different. So volume of the cone is equal to 1/3 pi r square h. Either this capital R and h is both are variables. So we have to convert into one variable. So which is 1/3 into pi into r square. R square can be written as small r square minus x square, because that's a right triangle. From there you will get capital R square plus x square is equal to small r square. So from there आपको r square is equal to, means capital R square is equal to small r square minus x square मिलेगा. Correct? Then h is equal to, it is already मैंने बताया, it is r plus x. Now we can see that it is in one variable because small letter r is constant, because it is a radius of the sphere, it is fixed. So now either you can expand, नहीं तो directly आप कर सकते हैं. Expand करेंगे तो 4 term आएगा, which is like this 1/3 pi into r square into r cube plus r square into x, r square x minus r x square minus x cube. Now we have to find derivative dA by dx 1/3 pi constant, 1/3 pi constant, r cube is constant, derivative 0, then r square is constant into derivative x is 1 minus r into derivative of x square is 2x minus x cube derivative is 3x square. Now dA by dx is equal to 0 implies ऊपर का derivative 0 होना चाहिए. So 1/3 pi constant, that won't be 0. That means r square minus 2rx minus 3x square is equal to 0. तो उसको फैक्टराइज कर सकते हैं. जो r r इंटू r स्क्वायर आएगा. लास्ट टू टर्म्स का प्रोडक्ट, लास्ट टर्म ऑफ द फर्स्ट एक्सप्रेशन, लास्ट टर्म ऑफ द सेकंड एक्सप्रेशन, उसका प्रोडक्ट माइनस 3x स्क्वायर आना चाहिए. सो हो सकता है x एंड 3x होगा. अब चेक करना पड़ेगा x एंड 3x. सो एक तो माइनस आना चाहिए, तो एक जगह तो माइनस आना चाहिए. सो प्लस x माइनस x, हम चेक करना बराबर आते हैं क्या. x इंटू r x r, then r into minus 3 rx, so minus 3 rx plus rx, so minus 2 rx, so बराबर आएगा. So which is equal to 0. Otherwise what you have to do is you can write this as, देखो इसको आप ऐसे लिख सकते हैं, माइनस से मल्टीप्लाई करेंगे तो 3x square plus 2rx minus r square is equal to 0. This is a quadratic expression. Variable x is the variable. So you can say a is equal to 3, b is equal to 2r, c is equal to minus r square. So then minus b plus or minus under root b square minus 4ac divided by 2a वो यूज करके आप सोल्व कर सकते हैं. नहीं तो डायरेक्ट हम फैक्टर्स, जो फैक्टराइजेशन करना आता है तो डायरेक्ट फैक्टराइज भी कर सकते हैं. That means r plus x is equal to 0 or r minus 3x is equal to 0. That means x is equal to minus r, but this is not possible क्योंकि x is a length, it cannot be negative. That means r is equal to, or 3x is equal to r, x is equal to r by 3. तो हमें क्रिटिकल पॉइंट मिला है, इट इज r by 3. अभी उसी पॉइंट में वॉल्यूम मैक्सिमम है करके दिखाना फर्स्ट. सो उसके लिए सेकेंड डेरिवेटिव चाहिए. सो डी स्क्वायर ए बाई डी एक्स स्क्वायर. सो 1/3 पाई तो कांस्टेंट है, 1/3 पाई इज कांस्टेंट. देन r square is constant, derivative 0, minus 2r into derivative x is 1 minus 3 into derivative x square is 2x, so minus 3 into 2, 6x. So you can take, if you want 2 also common, minus 2 also common, so minus 2/3 pi in bracket r plus 3x. Now we have to find the second derivative, d square a by dx square at the point x is equal to r upon 3, which is equal to minus 2/3 pi r plus 3 into r by 3. So anyway 3 cut हो जाएगा, r plus r 2r, whatever it is positive, and positive into a negative, it is negative. That implies area, sorry, volume. So मैंने इधर भी वो ये यूज़ किया, इधर you have to use any alphabet you can use, but already मैंने ये यूज़ v यूज़ किया था, so you have to use v. d square v by dx square dv by dx, so dv by dx like this, क्योंकि मैंने वो लेटर यूज़ किया था v. So therefore v is equal to, so that means volume is maximum at x is equal to r upon 3. But our question is to prove that it is at that time altitude is 4r by 3. So when x is equal to r upon 3, height is equal to, हमें पता है height is equal to r plus x, so which is r plus x is r upon 3, so 3r plus r, 4r upon 3. ठीक है, so we proved that the volume of the cone is maximum, and it is maximum when x is equal to r upon 3, and at that time height of the cone is equal to 4r upon 3. Okay, this is the last question we are going to discuss. Show that the height of the cylinder of maximum volume that can be inscribed in a sphere of radius r. So here also you can see that height of the cylinder of maximum volume that can be inscribed in a sphere of radius r. That means sphere is fixed. It is fixed. Sphere is fixed. And we are going to inscribe a cylinder in this. We are going to inscribe a cylinder in this. Like this. So here is the center of the sphere. हमें ये प्रूफ करना है कि volume of the cylinder is maximum when height of the cylinder is equal to 2r divided by root 3. This is what we need to find. Also we have to find that maximum volume. What is that maximum volume? That also we have to find. This is the question. So हम ऐसे कर सकते हैं. You can take the height of the cylinder is equal to h, and we can take the radius or the base, full base means the diameter, you can take it as x. So you can take the radius as x also, then diameter will become 2x. It is up to you, nothing wrong in that. Then you can see that here this complete length, this complete length is 2r, क्योंकि this is r and here is also r, so the total length is 2r. Okay, we need a formula to the thing which is to be maximized or minimized. So volume of the cylinder, volume of the cylinder is pi r square h normally. So here r is equal to x by 2, so which is pi x by 2 ka square into height, so which is 1 by 4 pi x square into height. So you can see that there are two variables, x and h, but from this right triangle, here is a right triangle, you can see x square plus h square is equal to 2r ka square, that is 4r square. So from there आपको मिलेगा h square is equal to, so which is equal to 1 by 4 pi x square into, नहीं तो आप x square को सब्स्टिट्यूट कर सकते हैं, क्योंकि हमें तो you can substitute for x square or you can substitute for h square, doesn't matter. So इधर हमें height चाहिए था, height of the, so you can substitute for height. Even if you substitute for x, nothing, it is not a problem either. You can substitute for x, you can substitute for h, no problem at all. So it is 4r square minus h square into h. So which is multiply करेंगे तो 1 by 4 pi into, in bracket 4r square h minus h cube, 1 by 4 pi से multiply करें तो 4 कट हो जाएगा, pi r square h minus 1 by 4 pi h cube. Now you got the thing which is to be minimized or maximized. We have to find the derivative. So dv by dh, pi r square constant, derivative h is 1, minus 1 by 4 pi 3 h square. So now dv by dh is equal to 0 implies ऊपर का expression 0, that is pi r square minus 3 by 4 pi h square is equal to 0. That means 3 by 4 pi h square is equal to pi r square. So pi दोनों साइड से कट हो जाएगा. So h square is equal to 4r square divided by 3. So आपको मिलेगा h is equal to 2r divided by root 3. Now you have to find the second derivative, d square v by dh square, so which is pi r square, h is constant, so h is derivative is 1, minus sorry dv by dh, इधर है dv by dh, pi r square derivative 0, minus 3 by 4 pi constant, h square का derivative 2h. Now d square v by d h square at h is equal to 2r by root 3, which is minus 3 by 4 pi 2 into h is equal to 2r by root 3. So it is less than 0 क्योंकि माइनस से मल्टीप्लाई करें बाकी सब पॉजिटिव है. So remaining you have to do because there is no enough time. So now derivative is 0 at h is equal to 2r by 3. That is we proved. Now what you have to do is you have to find the maximum volume. So volume को r का वैल्यू मिला, h का वैल्यू निकाल देना, then substitute कर देना. ठीक है. So that part you have to do. And also today is our today no, not today, tomorrow is our doubt session, so be ready with the doubts. Okay, इसका बाकी आपको कंप्लीट करना है. Is it clear?